And now on to the next one, which is number 3. So for this one, we're going to first make a table of values just to see what's going on. We're going to plug in the same numbers, but something interesting is going to happen with this one. So here we are again at the property of exponents. The first one we're plugging in is -2. 1/2 to the -2 power is the same thing as taking the reciprocal of the inside where the exponent will turn positive. It becomes the number 4. -1 also does the same thing. It just calculates the reciprocal, which is the value of 2. Anything to the first 0 power is 1. Anything to the first power is itself. And instead of putting 1/2, I'm just going to put 0.5. 1/2 to the second power is 1/2 times 1/2. Same thing as 1/4. Same thing as 0.25. With these values, I will graph. So, -2, 4. -1, 2. 0, 1. 1, 0.5. And 2, 0.25. And then to the best curve you can make, try to connect those. Notice it has the same curve, but it's a little different this time. Also notice that it seems to be approaching y equals 0, but never touching it as well. That means we still have the same asymptote of y equals 0. Your domain. Your domain is all real numbers. And the reason it's all real numbers is because you can plug in any type of x's and you would still get a value for y. Your range is different, however. Notice in your graph that you do not even have any negative y values or even the number 0 as a y value. So your range is 0 to infinity. And this is the same as saying y is greater than 0. Your end behavior, as x is approaching positive infinity, means to the right. So I will be tracing it to the right, and you can see that it is approaching something. It is approaching 0. And as x is going to the left, same thing as saying negative infinity, you'll see that the y values are doing something. They are increasing, which means positive infinity. Your y-intercept we found by plugging in 0 to find out that the correct answer is 1. And that's how you graph number 3. To graph number 4, you can kind of tell that there's some kind of pattern going on. That 2/3 is less than 1. So just like the previous question we did, you'll see that it is not exponential growth, but rather exponential decay. So to prove this, I'm going to plug in the same numbers. I'm going to plug in -2 first. Remember, -2 can be also written as the reciprocal of the original, and the 2 will turn positive. 3 times 3 and 2 times 2 will give you your final answer of 9/2. Same thing as writing 2.25. 2/3 to the negative first power is the same thing as doing the reciprocal. And the reciprocal would be 3/2. Same thing as saying 1.5. Anything to the 0 power is 1. anything to the first power is the same. 2/3 being approximately 0.6 repeating. And 2/3 to the second power is 4/9. And 4/9 is approximately 0.4 repeating. So these are the values we're going to try to plug in. -2, 2.25. -1, 1.5. 0, 1. 1 and 2/3. And 2 and 0.4. Not my best graph, but you can still see the curve. Notice that this curve also does not dip down into a certain number. And yes, that same number that we've been talking for the last 4 questions, you have the same asymptote of the number 0. Because there's no value you can plug into this x to make f of x 0 or less. So your asymptote is y = 0. Your domain. Can you plug any kind of x and still get a value? Yes. But your range, the graph, only hits certain kind of numbers, and those are positives. So you can write it as parentheses 0 to infinity, which means you are not including 0, or you could write it as y is greater than 0. As you're going to the right, you can see that the function is approaching something. It is approaching the number 0. As you're going to the left, you can see the graph is doing a certain kind of behavior, which is up. Same thing as saying f of x is approaching positive infinity. Your y-intercept is 0, 1. And now for number 5. Number 5 is a tricky one. You just have to look at your b. Notice that 5/2 is actually greater than 1. So they were trying to trick you on this one. This will be an exponential growth function. So here we go again with -2, -1, 0, 1, 2. And first I'm going to plug in -2. Another way of evaluating this is to do 5 to the -2nd power and 2 to the -2nd power, which means they would both change their positions and then be evaluated as positive exponents. 4/25, same thing as 0.16. The next one is the -1st power. Notice that the -1st power is the same as just taking the reciprocal, because it would be 5 to the -1st power and 2 to the -1st power, which would be 2/5. Same thing as saying 0.4. Anything to the 0 power is 1. Anything to the 1st power is the same thing, can be written as 2.5. And 5/2 to the 2nd power is 25/4. And 25/4 as a decimal is 6.25. And now to graph. -2, 0.16. -1, 0.4. 0, 1. 1, 2.5, and 2, 6.5. Again, not the best, but we'll connect it. And we still have the same asymptote despite being exponential growth. And the asymptote will be y equals 0. Your domain are all real numbers. Your range is only whatever values you have on the graph, and we only have positive numbers. Same thing as saying 0, infinity without 0 being included. Same thing as saying y is bigger than 0 without including 0. As you're going to the right, you can see that my graph is increasing, which is positive infinity. As you're going to the left, you can see that the graph is approaching a number, and the number is 0. Your y-intercept would be 0, 1.